Hey Nine, so I just wanted to quickly go over combining like terms. So when we combine like terms, what we do is we want to simplify this expression so that it has one of every term in it. So if we take a look here, we have x cubes, right? We have a bunch of x cubes, we have a bunch of x's, and we have a bunch of numbers. And so if you remember the definition for a like term, right? So we say when we're talking about like terms, we are talking about terms that have the same variables, right? They have the same variables, and their variables have the same exponents. So x and x cubed are not like terms, but x cubed and x cubed are like terms. So they have the same variables, and the variables have the same exponents. All right, so let's take a look at this expression at the top here then, because we want to simplify it. So here we have a 3x cubed, right? And then we have a negative 5x cubed. And then we have a 12x cubed. Now, the reason I started with x cubed was because that was my highest power. So I like to start with the highest power when I'm simplifying these equations. And actually from a notation point of view, or sorry, these algebraic expressions, and from a notation point of view, we do normally write our expressions in terms of the exponents. So anything to the 3 would come first, and then if there was an x squared, those would come next, and then x's, and then numbers. So let's take a look at this one then. So I have all of these x cubed expressions, and I want to put them all together, so I'm going to move them around. And it's okay if I move things around, because if you think of the fact that if you have 2 plus 5, well, that equals 7. And if you have 5 plus 2, well, that equals 7 as well. So this, right, I've just rearranged the order. So I've taken the 5 to the front and moved the 2 to the back. Now, one thing you'll notice, though, is that when I rearrange the order, all of a sudden, where their signs have now here there's a plus in front of the 2 where there was no plus in front of the 2 here, and here there's a plus in front of the 5 where there was no plus in front of the 5 here. And that's because anytime you have you're writing an expression, if there's no plus sign in front of it, there's an implied plus. All right, so we know this is plus 2 because if it was a negative number, there'd be a negative sign in front of it. And here there is also an implied plus. Okay, so let's go back to our expression. So we have 3x cubed minus 5x cubed plus 12x cubed. Now, when we move them around, we take the signs with them. Okay, so we're going to write 3x cubed, and then we're going to write negative 5x cubed, or subtract 5x cubed. So I've taken the subtract sign with me. Okay, it's in both places. And then I have plus 12x cubed, so I'm taking the plus sign with me. And then I have 12x cubed. So next I have negative 2x. I'm going to, because I don't have any x squared. So I have my negative 2x, and then I have another x term. So I'm going to write those two together. So again, I take the sign with me, so I take the negative, and then I have 2x, and then I take the positive, and I have 11x. And then all I have left is this 9 and 7. So I take the signs with me, so I have plus 9 and minus 7. So now everything's in order, and it's a lot easier to do the math on it. So when I add like terms, the rule is that you add the coefficients, or subtract, add and subtract the coefficients, but that the variables stay the same. And the reason for this is, if you think of them, the variables are just replacing, say, words. So if you had 3 apples and then you gave away 5 apples and you got 12 apples back, you wouldn't have any, the apples are the thing that you're talking about. And so here we're talking about 3 of these x cubes minus 5 of these x cubes plus 12 of these x cubes. So we add and subtract the coefficients, but the variables stay the same. So what we're going to do is we're going to just work with those numbers. So what I recommend doing is, because many of us still have a difficult time with integer rules, is doing this in your head. So 3 minus 5 is negative 2, plus 12 is 10, and then check it on your calculator to make sure that you got the right answer. So then we would have 10 of these x cubes, right? So I'm going to do the math down here. So I've got 3 minus 5 plus 12 which equals 10. Then I have negative 2 plus 11. So I'm going to do negative 2 plus 11, and that is going to equal 9. Now, anytime I write an algebraic expression, I have to write it, it's always the addition and subtraction of terms. So I have to write this with either an addition sign in front of it or a subtraction sign in front of it. And because this is a positive number, it's going to have an addition sign. So it's going to be plus 9x. Okay, so again, there's an implied positive here, and so you have to write the plus sign here. And then I have my 9 subtract 7. So I'm going to come over here. 9 subtract 7 equals 2. And so here, but again, it's a positive 2, right? So I'm going to write plus 2. So when I simplify this expression, 3x cubed minus 2x plus 9 minus 5x cubed plus 11x minus 7 plus 12x cubed, I get 10x cubed plus 9x plus 2. So let's take a look at one more to make sure that we have it. Okay, so I'm going to do 4 y to the 5th minus 7y cubed minus 8y to the 5th plus 9y squared minus 2y plus 9y cubed. All right, so again, the first thing I want to do is I want to put all my like terms in order. So I take a look at my variables. So here I have a y to the 5th. And here I have another y to the 5th, and I've circled it with my signs. Then here I have a 7y cubed, right? So I'm going to take the sign. And here I have a 9y cubed. So these are like terms. And then these ones exist, but there's no other addition or subtraction that I'm going to have to do with those. So first I'm going to look for the highest power, so 5. So I'm going to rewrite this as 4y to the 5th minus 8y to the 5th. Then I'm going to look at the next highest power, so that's 3. So it doesn't matter which one of these I take next. I could take this one. So I have plus 9y cubed and the minus 7y cubed. And then the next one is my y squared, so plus 9y squared, and then I subtract my 2y. Okay, so now I just have to add up the coefficients. I'm going to come over here again to do my scratch work. So I have 4 and 4 minus 8, so that equals negative 4. So I'm going to come here, and I've got the sign already, so I don't have to worry about it. So I have negative 4y to the exponent 5. So then the next ones, I have 9 subtract 7. So I have 9 minus 7, which equals 2. That 2 is positive. So I'm going to do positive 2y cubed. And then I have the 9y squared. There's nothing else there, so I just write it. I don't have to add anything to it. And then I have my minus 2y, and there's nothing else there, so I don't have to add anything to it. So now I have I have added and subtracted everything in here that can be added and subtracted, and I have my simplified expression. So I'm going to do quickly one last one, just so that you can see what happens when we have variables that look similar but aren't. So let's say I have 12x squared y minus 3yx squared plus 7y squared x minus 11x squared y plus 2y squared x. Okay, so when I'm looking at these expressions, if I go all the way back to the beginning of this video, I said like terms have the same variables and the variables have the same exponents. So if we go down here and we start looking at our like terms, so here I've got 12x squared y, and I'm looking for another 12x squared y, and so I have a negative 11x squared y. But then when I look here, I'm like, it looks different, but it's not, because the y there's a y, and there's an x squared, and there's an x squared. So that means that all three of these are actually the same. Even though we've written them in a different order, it doesn't matter because the variables are the same and each of the variables has the same exponent. So y and x squared and x squared. So now I can come down here. Oops, sorry. Then I have 7y squared x, and then I have another y squared x. Okay, so now I'm going to come down here and I'm going to do the 12 minus the 3 minus the 11. But before I do that, I actually want to write them in order. So I'm going to take this one first, 12x squared y. Then I'm going to do this one. So I take the sign with it. So minus 3y x squared. Then I go over here. I take the sign with it. So to plus 2y squared x. Oh my goodness, I totally wrote that one wrong. Ignore me. I want this one, so I take the sign with it. So I have 11x squared y. Then I look for these two like terms. So I have the plus 7y squared x plus 2y squared x. So now I add up the like terms. So that's these three. So I'm going to add the coefficient. So 12 subtract 3 subtract 11, which is negative 2. So this is going to equal negative 2 x squared y. And then I look at these two, and I have 7 plus 2, which equals 9. And it's a positive 9 because it's not negative. So then I'm going to write plus 9 y squared x. And these are not the same, right? Because this has a squared, whereas here the variable doesn't. It's just x to the 1. And this has a squared, and it's y to the 1. So I am done. I can simplify no further. Hope that helps.